One of the most vital safeguards in operating your aircraft is to perform routine pre-flight inspections of your propeller. Sometimes with the newest composite props, pilots are less certain about potential trouble signs. It's important to not only be able to identify problems before takeoff, but also determine whether any seemingly minor nicks and gouges are keeping your plane from being airworthy. Hartzell Technical Representative Kevin Ryan travels the world to teach pilots and technicians about composite propeller repair and maintenance. Today, he'll teach you.
Good morning. Today, we're going to be learning how to perform a pre-flight inspection on a Hartzell Raptor series propeller. You'll notice I refer to it as a Raptor series propeller. This propeller is a completely new design. Hartzell propeller that you'd be used to doing an inspection on would normally start with a model number that would have HC in the model number, maybe a PHC, EHC, DHC, something along that line. This propeller, as a Raptor series propeller, has a different model number. This model number is a 3C-919A1, and the blades installed are 76C03-2. It's a different model, and the pre-flight inspection on this propeller is slightly different than a Hartzell propeller that you may be used to using. The first inspection to perform is a visual inspection of the blades. You'll want to check the blades for nicks, gouges, loose material, erosion, cracks, debonds, or delaminations. Nicks and gouges that penetrate the composite material need to be evaluated. A damage in the paint itself is not an issue. Loose material often appears on the trailing edge of the blade, generally due to an impact. You'll want to inspect the trailing edge of the blade, especially for loose material, although it could appear elsewhere on the blade. Also, examine both the face and camber side of the blade for cracks, debonds, or delaminations. You may find a crack in the leading edge of the blade. That crack could also be associated with the debonded area. Usually that will show up as a raised area on the leading edge. A delamination of the composite material itself normally appears as a raised area on the blade. Both of those can be inspected using a coin, and listen for a dead area in the damaged area. You'll hear a nice ring as you do your coin tap. A dead area will sound much different than a bonded area on the blade. All of those limits for nicks, gouges, loose material, erosion of the paint, cracks, debonds, delamination, can all be found in Hartzell Manual 170, which is on our website. The next item to inspect is the spinner assembly. You'll want to inspect the spinner dome for cracks, looseness, missing hardware. Inspect the hardware that attaches the spinner dome to the spinner bulkhead. Make certain that all the hardware is in place and that it's tight. Also, inspect around the hardware to determine if there's any cracks that come from around the hardware. Also, check around the opening for the blades to make certain that those areas aren't cracked. You can find cracks on other areas of the propeller, but these are the most common areas to find cracking. Once that inspection is complete, you'll want to inspect the spinner as a whole, make certain that it's firmly attached to the bulkhead and to the propeller. The next item to inspect is the de-ice or anti-ice boot installed on the blade. Make certain that the de-ice or anti-ice boot is firmly bonded to the blade within the limits as published in Hartzell Manual 181, which is also on our website. A blade that does not have an anti-ice or a de-ice system will have erosion tape installed. This blade, for example, has erosion tape installed. Do not fly the aircraft if the erosion tape is not installed, as it can cause excessive erosion of the blade on the inboard portion of the blade. The next item to check is check the interior of the spinner, looking for grease or oil leakage or loose material. Some grease or oil may be present, but it shouldn't be excessive. Grease or oil leakage that travels down the length of the blade or spatters up on the windscreen during operation is not acceptable. But a small amount of grease or oil is fairly normal. Use a strong light source and look inside the opening of the spinner. Check for loose material. If you have a de-ice system installed, for example, make sure that the clamps and the wires are properly secured. Also, there may be some balance weights installed. You want to make sure that that hardware has not loosened and that the balance weights are in place.
While you're performing this inspection, note that you may have small, varying degrees of play from blade to blade. But as long as each blade is within limits, there's no cause for concern.
The last inspection to be performed is blade play. We'll be inspecting for blade radial play, in and out play, end play, and fore and aft play. Radial play is measured by attempting to change the pitch of the blade. At the reference station on the blade play should be no more than plus or minus 1/2 degree or 1 degree total. In and out play is inspected by attempting to pull the blade from the propeller hub. There should be very little to no movement in this inspection. The max limit for this inspection is 20 thousandths of an inch. End play and fore and aft play is performed a bit differently than it is on a Hartzell compact or a Hartzell lightweight propeller. On those propellers, you would be inspecting out here, moving the blade back and forth or up and down. On this blade, you'll want to grasp the blade here, approximately in the area of the propeller decal, with a thumb and a forefinger. You'll apply about 5 pounds pressure in the direction to be inspected. So, to check fore and aft play, for example, I will pull or push the blade fore and aft with about 5 pounds of pressure, and I'll measure the play out here at the tip. No more than 1/4 inch movement is allowed here at the tip for fore and aft play. For end play, I'll grasp the blade once again about the area of the decal and attempt to move the blade up and down. 5 pounds pressure once again, and once again I'm allowed about 1/4 inch movement. The reason this inspection is performed differently than it is on a Hartzell compact or a Hartzell lightweight propeller is due to the design of the preload system in the propeller. This preload system uses a different setup than a Hartzell compact or a Hartzell lightweight propeller. And it may feel a little bit different when you perform this inspection if you're used to performing this inspection on a Hartzell lightweight or a Hartzell compact propeller. These pre-flight inspections can be found in Hartzell Manual 480, which is on our website. As you can see, the pre-flight inspections for this propeller aren't that much different than that for an aluminum bladed propeller or a Hartzell compact propeller or lightweight propeller. The main difference is the blade play inspection, and if you perform those inspections properly, you should be happy with the propeller and enjoy your flight.
If you'd like to learn more about pre-flight inspections or have other questions about the safety and airworthiness of your composite propeller, speak to one of our technicians personally by calling Hartzell Product Support directly or by visiting hartzellprop.com.